Properties of parallel lines and proving lines are parallel. So before we get started with the theorems, let's review biconditional statements. Biconditional statements have the phrase P if and only if Q. So the conditional if P then Q and the converse if Q then P both have to be true. So in our case, we're going to be studying the original theorem, if two parallel lines are cut by a transversal, then something, and that something is going to change each time. And also the converse, if something, then the two lines are parallel. So let's look into this a little more specifically, and then we'll come back to talking about this. The corresponding angles postulate. Last time we talked about what corresponding angles were, and now we want to talk about the special postulate regarding parallel lines. So two parallel lines are cut by a transversal if and only if the pairs of corresponding angles are congruent. So this extra set of arrows here on the lines tells us that these two lines are parallel, and they're cut by a transversal. So the corresponding angles, remember the ones that are in the same positions, these two angles are going to be congruent because we know the lines are parallel. Likewise, this pair of corresponding angles will also be congruent. This pair of corresponding angles is congruent, and this pair of corresponding angles are congruent. Now, if you notice, I marked the purple and blue angles with 2 because those are also congruent to each other because they're vertical angles. Likewise, the green and red angles are marked with 1 because they're also vertical and congruent to each other. So remember, the postulate tells us that if two parallel lines are cut by a transversal, then you can say the pairs of corresponding angles are congruent. The way we would use the converse is if you're given corresponding angles that are congruent, then you can conclude for me that the two lines are actually parallel. So there's going to be a difference in what information you're given versus what you're trying to conclude. Alternate exterior angles theorem. It has the same idea. We have a biconditional theorem, but we want to talk about how it changes with alternate exterior angles. So it says two parallel lines are cut by a transversal if and only if the pairs of alternate exterior angles are congruent. So again, we have the parallel lines, so we know that the alternate exterior angles, the ones opposite sides of the transversal outside of the two lines, are going to be congruent to each other. And our other pair of alternate exterior angles will also be congruent. So again, think about the theorem versus the converse and what you're given and what you're trying to conclude. The alternate interior angles theorem says that two parallel lines are cut by a transversal if and only if the pairs of alternate interior angles are congruent. So we have the alternate interior angles are congruent because we know the lines are parallel, and the other pair of alternate interior angles are also congruent. The consecutive interior angles theorem says two parallel lines are cut by a transversal if and only if the pairs of consecutive interior angles are supplementary. So this is the only one that's a little different. The consecutive interior angles are going to be supplementary. The corresponding angles, alternate exterior and alternate interior angles, those pairs were all congruent. But remember, consecutive interior angles are supplementary. When you look at the consecutive interior angles, they're not going to be the same. Even by picture, even though you can't know the exact measure, this looks like an acute angle and this looks like an obtuse angle. It's not going to be possible for them to be the same. So you want to remember that, and I just made this note here to go with the diagram, an angle marked with 1 plus an angle marked with 2 equals 180, because that's what it means to be supplementary. So we have another pair of consecutive interior angles. So make sure that you're color coding your angles correctly. Otherwise, you might get confused when you look back at your notes and you're not really sure which pair we're talking about. So again, we have another pair of consecutive interior angles. This angle plus this angle are going to be supplementary, so their measures equal 180 degrees. Let's recap our discussion about the biconditional statements again. So each of these theorems or postulates was given as a biconditional if and only if. So for the conditional statements, it always started, and this is the actual theorem or postulate, it said if two parallel lines are cut by a transversal, then you can tell me that the corresponding angles are congruent, alternate exterior angles are congruent, alternate interior angles are congruent, and consecutive interior angles are supplementary. Using the converse, that'll be if I give you a diagram where the corresponding angles are congruent, alternate exterior angles are congruent, alternate interior angles are congruent, or the consecutive interior angles are supplementary, then you can tell me that the two lines are parallel. So we're going to go through a few examples that'll help clarify the difference of when you're using the theorem versus the converse. Let's take a look at these examples. We want to find the values of x and y and justify how we found each answer. So here we're given this diagram, and we need to note that we're given that extra set of arrows, which means those lines are parallel. So this angle is 70 degrees. Now, how do we find x? If you remember from Unit 1, angle x and 70 make a line, which means that they are a linear pair. So we're going to use the fact that they are a linear pair to find the value for x. Linear pairs are supplementary, and they add up to 180 degrees. So if this angle is 70, x has to be 110. So that's our justification. Now, when we want to find the measure of angle y, remember, we can go back to using what we talked about in the previous lesson. You can draw your circles here, and then if you notice, x is in the top left side of the circle. Y is in the top left side of the circle. These are corresponding angles. And we just learned today that corresponding, I think I spelled that wrong, corresponding angles are congruent. So this is a corresponding angles postulate. And that tells us that these are going to be congruent, so y is also equal to 110. Let me walk through the second one with you. We're given, again, note that these are parallel, so we're going to be using the theorems or postulate. This angle is 130. Again, to find x, we have another linear pair. So x and 130 have to equal 180, so that means x has to be 50 degrees. Now once x is 50, I want you to think about the relationship between x and y. So if we draw our circles to separate, x and y are outside of the two lines, and they're on opposite sides of this transversal. That makes them alternate exterior angles. So using the alternate exterior angles theorem, and we can abbreviate, we know that alternate exterior angles are congruent when we have parallel lines. So y is also going to be 50 degrees. Lastly, let's look at this example. So this angle here is 90 degrees. And then we don't have a linear pair here, so let's focus on those circles and see what relationships we can build. So again, that right angle is in the top left side. X is also in the top left side. That means they're in the same position, so these are corresponding angles. Corresponding angles postulate. We can use that to say that they're going to be the same. So 90 degrees is the measure for x. And then if you look at x and y, again, we have a linear pair. They have to add up to 180 degrees. So if x is 90, y also needs to be 90 degrees. So this is how you find your answer for the variable and justify your answer. So here are 3 more examples. I want you to try these on your own. So pause, draw the diagrams, find the value of x and y, and give your justification. And then check back with me when you're finished to see how you did. Okay, let's talk about these one at a time. For example 4, hopefully when you drew your circles, the very first one that you can find is x. 120 and x are both inside the 2 lines, and they are on the same side of the transversal, so you can use the consecutive interior angles theorem. And yes, I abbreviated a lot. This is my symbol for angles, so you can abbreviate also. So the consecutive interior angles theorem says that these angles are supplementary, so they have to add up to 180. That means x has to be 60. Then if you notice here, x and y, these are vertical angles. And so, using the vertical angles theorem, we can say that y is equal to 60 degrees. In example 5, here we have 115 and x are vertical angles. So we use vertical angles theorem to say that x is 115. And then once we've said x is 115, it's in the bottom left and y is in the bottom left of the circle. So we can use the corresponding angles postulate to say that y is going to be equal to 115 degrees. On this last one, it's actually easier to find y first. 100 and y, these make a linear pair, so we use the linear pair postulate to say that y is 80 degrees because they need to be supplementary. And then angle y and angle x are alternate interior angles, so we use the alternate interior angles theorem to say that x is 80 degrees and congruent to angle y. So now we want to use those theorems to find the value of x. So it's kind of like what we did before, except we have expressions this time and we're going to need to set up an equation to solve for x. So if it does help, go ahead and set up your circles. Now we might not get the whole expression in there, but it's okay. We want to focus on the angles. So we're talking about this angle here and this angle here. They're both inside the 2 parallel lines and they're on opposite sides of our transversal. So that means these are alternate interior angles. You don't have to write it, but if it's going to help you remember, you can write alternate interior angles. And you should remember that alternate interior angles are congruent, which means the same. So that means 2x minus 10 is the same as 80. So they're equal to each other. Now this is the equation we set up, and then let's solve for x. Add 10 to both sides. Then we have 2x is equal to 90. Divide both sides by 2. And we have x is equal to 45. So our final answer is x equals 45. I want you to go ahead and try example 8 and then check back with me when you're finished. Now when you work out example 8, hopefully you recognize that angle 120 and the one labeled 3x, those are consecutive interior angles. They're on the same side of the transversal and they're inside the 2 lines. And remember, consecutive interior angles are supplementary. So this time you have to take 180 plus 3x equals 180. Sorry, 120 plus 3x equals 180. Then we can solve that equation. Subtract 120 from both sides, and then we have 3x equals 60. Divide both sides by 3, and we get x equals 20. So be careful about consecutive interior angles. Remember, these are the ones that are supplementary, not congruent. So make sure you set up the correct equation. Go ahead and try example 9 and check back with me when you're finished. So hopefully you recognize that the angle marked 135 and 3x plus 15, they're both in the top left side of the circle. So they're corresponding angles. And remember, corresponding angles are congruent. And that means the same. So 3x plus 15 is the same as 135. So they're equal to each other. Then subtract the 15 from both sides, divide both sides by 3, and you should get an answer of x equals 40. Now we want to shift into a different type of problem. It says, is it possible to prove that lines P and Q are parallel? If so, explain. So this is actually where we're going to start using the converse. So as you can see in the diagram, we're given two lines, and I know they look like they're parallel because that's how the picture looks. But don't be fooled. We have to use the facts that we're given. We have to use the relationship between these angles and what we know about certain angles being congruent or supplementary, and then decide whether it's enough information to prove that P and Q are parallel. So whenever we're trying to prove the lines to be parallel, that's where we're actually going to be using the converse of the theorems we talked about today. So first, just for visual help, and you might not need them, but we're going to draw our circles. And let's talk about what angles we have. 70 is in the top left, 70 is in the top left. So these are corresponding angles. Now, are corresponding angles supposed to be congruent? Yes, they are. So since the corresponding angles are congruent, we're using the converse to prove that P and Q are actually parallel. So we can say, yes, they are parallel. So remember, we're always going to be using the converse if we can prove that the lines are parallel. So because the corresponding angles are congruent, that is enough information to say P and Q are parallel. Let's try the second one together. If we draw the circles, again, just for visual aids, okay? Let's talk about these angles. We have 130 here, and 50 is a different measure. Now they're both inside the two lines, and they're on the same side of the transversal. So we're talking about consecutive interior angles. Now, 130 plus 50 equal 180. That means they're supplementary. So ask yourself, are consecutive interior angles supposed to be supplementary? And the answer is yes. So that means we can use the corresponding interior angles converse to prove that P and Q are actually parallel. Let's take a look at this last one. This one might be a little tricky, so let's make sure we work through this together. So if we put our circles there just for reference, this 75 is in the top left side. This 115 is in the top right side. They're not in the same position, so they're not corresponding angles. So let's check the other ones. 75 is outside of line P, but 115 is inside of line Q. So the only other angles we can talk about are interior angles and exterior angles. But if you have one that's outside and one that's inside, they actually don't match. So what is something we can say is true? 75 and this angle right here, this unknown one, those are going to be supplementary because they're a linear pair. So if we take, and this is side work, 180 minus 75, that's going to give us 105. So this angle is actually 105. Now, 105 and 115 are corresponding angles, and corresponding angles are supposed to be congruent. But 105 and 115 are not congruent. So we can use the corresponding angles converse to say no, P and Q are not parallel. So that's it for today. Make sure to submit any questions if you have any, and I'll see you in class for more practice.